Great. Mr. Hahn coming to you live from Cross Lutheran School. Still kind of dark outside, still kind of early, but we're going to talk ourselves a little mathematics, and we're talking about probability. So it would probably not be nice if you pulled out some of your note paper. I'm pretty sure we've talked probability before, so you should have something there that talks probability. Find the pen. Let's see what we got going on here. And it is probability. Probability. And we don't really have to define that. Remember, that is the likeliness of something happening. Likeliness. Is that spelled right? Likeliness. Yeah, whatever it is. Likeliness of something happening. And here's the deal. What's going to happen now is it's kind of the multiple things happening. For example, if you were to flip a coin on a coin flip, if I asked you the probability, let's say you flipped it twice, of getting a head and then getting a tail. One thing you can do is, probability is your desired outcome. How many of those? Your desired one over total outcomes. One way to do it is you need to try to figure out all your different possible combinations of that. One way to figure that out is, this is kind of the hard way, so is to draw a tree diagram. You could do it like this. In your first flip, you get a head or you could get a tail. Then in your second flip, you could also get a head and you could get a tail off of each one of these. So this is a way to keep track of all your possible combinations, because this would mean this. Your combinations are this: a head and a head. Put those two heads together, you get head, head. You get a head, tail. You get a tail, head. And you get a tail, tail. So you have 1, 2, 3, 4 total combinations. How many of them are a head and then a tail? Well, there's only one here. So your probability when you flip a coin of getting a head and a tail is 1 out of 4. Let's look at that again in super slow motion. Let's say we were doing something else. Let's say we were rolling a dice. So you had dice and a coin. And I wanted the probability, well, let's do it like this, of flipping a tail and then rolling a 3. Okay, again, if I were drawing a tree diagram of this, this time I'll just do it sideways just so you can see it doesn't have to be this way. For your first event, you could flip a head or you could flip a tail. And then for your second event, off of each one of them, you could either roll a 1, a 2, a 3, a 4, a 5, or a 6. So head 1, head 2, head 3, head 4, head 5, head 6. And again, I could write that down as head 1, head and a 2, head and a 3, head and a 4, head and a 5, head and a 6. Same thing off the tails. You could get a tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. It's your little branches of your tree. So tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So if you look at this, how many different combinations there are, you would count, there would be 12 combinations. Okay, and then the other, how many of them are tail 3? Well, it's right here. There's only, again, one of them. Now, I could ask you, it doesn't have to be as specific as that. I could ask you to give me the probability of a head and an even number, in which case I still have 12 outcomes. But how many are head even? 1, 2, and 3, head 2, head 4, head 6. So 3 12s, which is 1/4. Now, something you'll realize here is that if you're looking for the total possible outcomes, okay, if you're looking for the total possible outcomes, there's some goofy thing in the book called the, let me read it for you. I don't care if you necessarily know. It's called the fundamental counting principle, where if you're looking, you look at where we got this 12 from, the 12 really comes from, in your first event, there's 2 choices. You can get a head or a tail. In my second event here, I could get a 1, 2, 3, 4, 5, or 6. That's 6 choices. And how many total choices I have is what you get when you multiply those different choices together. Same thing here. I had 2 choices when I flipped the coin the first time, and 2 choices when I flipped the coin the second time. So that's a grand total of 4 different events. Now, rather than having to draw these tree diagrams all the time, okay, there is this rule, and this is what we should write down, that says the probability of 2 events happening is the probability, is their probabilities, is the probability of each multiplied together, which may or may not mean anything to you, but I'll show you what that means is this. You really don't, unless they ask you to draw a tree diagram, you really don't have to show all the possible combinations. They might ask you to give the sample space, in which case you do. But going back to my probability of this one right here, let me redo that. Let's change colors. Now we got blue going on here. So if I was looking at the probability of a tail and then a 3, well, the probability of getting a tail is 1/2, right? Because 1 out of the 2 sides of the coin is a tail. The probability of getting a 3 is 1/6, because there's 6 sides, only 1 3. The probability of both of them happening are these 2 probabilities times themselves. So 1/2 times 1/6 is 1/12. Okay, another example. Let's say I'm rolling a dice. Let's say I have a dice. Here's my little dice. I'm not real good at drawing these things yet, but let's say that's 1, 2, whatever, 3. And I have a spinner. And my spinner is cut into 4 pieces. And they are, I don't know, red, blue, green, and yellow. And I wanted you to tell me the probability of rolling a 6 and then spinning a yellow. Okay. Rather than doing the whole sample space of that thing, you can just do this. What is the probability of rolling a 6? Well, there's 6 sides to a dice. There's only one of them that's a 6. What is my probability of spinning a yellow? Well, there's 4 combinations there, and only one of them's yellow. What is the probability of both things happening? 1 out of 24. 1 out of 24. Let's see what else they ask you here. I'm also going to give you, Mrs. LeBeau will have this sheet for you, just because dice seem to come up a lot in mathematical world, so it's good to kind of have it. And this is a table, see if I can explain this to you. This is a table of all the different outcomes when you roll 2 dice. Okay, so here's the first dice. You can either roll 1, a 2, a 3, a 4, a 5, or a 6. Second dice, you can roll 1, 2, 3, 4, 5, 6. So, this kind of gives you quickly, first of all, there's 6 possibilities here and 6 possibilities here. So the white stuff are all the different sums that you can get. You roll a 1 on one dice and a 1 on the other, you get a 2. Okay, there are 36 different combinations when you roll 2 dice. Because again, we said our choices are 6 here, 6 there, multiplied together. Okay, and then this is all the numbers you get. So like if they ask you the probability of rolling a 7 on 2 dice, Okay, you have it right here. There's 1, 2, 3, 4, 5, 6 out of the 36 possibilities is a 7. So you have a 1 in 6 chance of rolling a 7. Whereas what's your probability of rolling a 12? There's only one of them, so it's just 1 out of 36. You don't get double 6s very often. Oh, well, I mean, and that's because that's the only combination that will give you a 12 there. But refer to this table if they ask you about, well, I probably gave it to you for your notes under probability. So, but they might ask you, if 2 number cubes are rolled, how many possible outcomes are there for which the first roll is even and the second roll is even? So here is your, let's write that down, the probability of my first roll being even and my second roll being even. So here is my first roll. Okay, how many evens are there? 1, 2, 3. So 1/2 of the things are even on the first roll. How many of the second roll are even? Again, same thing, it's 1/2. The probability of both of those happening is 1/4. And you can see what numbers you would get for them both to even. Let's do a different color. You know, I could roll a 4, they'd both be even, a 6, an 8. You know, you can go boom, 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 8, 10, and 12. And if you look at those, you have 9 of the 36 combinations. Gives you that beautiful 1/4 probability. But you did that right there, so you don't have to do it. So hopefully 7th grade, that kind of gives you just a little bit of a lead in on probability. It's fun, it's exciting. Thanks for tuning in. I shall end the session now.